Here in the I button and description box below, you will get the complete playlist of multiple integrals. Welcome to video number 10, and in this particular video we are going to solve third problem on the topic, that is triple integrals. This problem is very important. If you go to the playlist, in video number 8 we have solved this problem. Okay, in video number 9 we have solved this problem, and in this video, that is in video number 10, we are going to solve this problem, and all the three problems are equally important. So let us start with the last problem on the topic, that is triple integrals. The question says evaluate integral limit goes from 0 to 1, integral limit 0 to root over 1 minus x square, integral limit goes from 0 to root over 1 minus x square minus y square, function is x, y, z, and order of integration is dx, dy, dz. First of all, we need to check whether this order is okay, or we need to change this order of integration. Okay, for that we need to see the limits. Here we have limit, that is 0 to root over 1 minus x square minus y square. So here, since we had x and y, so we can say this is the limit of z, because z is a function of x and y. Now, if this is the limit of z, then these two are limit of x and y respectively. So here we need to, you can see we have x, that is limit goes from 0 to root over 1 minus x square. So since we have x here, so we can say this is the limit of y, because y is a function of x. Okay, I am repeating this once again. Here we have x and y, so we can say this is the limit of z. If this is the limit of z, then one has to be x and one has to be y in either of these two limits. Since we have x here, so we can say this is the limit of y. So we can say limit of y goes from 0 to root over of 1 minus x square. This is the limit of z, this is the limit of y. Then this has to be the limit of x. So we can say limit of x goes from 0 to 1, that is limits of x are constant. Okay, so x limits are constant, y is a function of x, and z is a function of x and y. Now here we have z, so we need to integrate this function with respect to z first. Okay, so this has to be dz. Then we have y, so dy position is okay. Then we have x, so here we need to put dx. So the order would be dz, dy, dx. This has to be the order of integration. So let I equals to integration 0 to 1, integration 0 to root over 1 minus x square, integration 0 to root over 1 minus x square minus y square. Here the function is xyz, so writing the function that is xyz, and the order of integration would be dz, then dy, then dx. Okay, so first we will integrate this part, that is integrating this function with respect to z, whose limit goes from 0 to root over 1 minus x square minus y square. Okay, so solving this part, so integration 0 to 1, integration 0 to root over 1 minus x square, integrating with respect to z, so this is going to be x y z square upon 2. Limit goes from 0 to root over of 1 minus x square minus y square. Then don't forget to write this dy and dx in the same order. Okay, now putting the limits in place of z, because we have integrated this function with respect to z. So in place of z, we will put lower limit as this and upper limit as root over of 1 minus x square minus y square. So this is going to be, yes, integration 0 to root over of 1 minus x square x y upon 2. Here in place of z, we are putting this upper limit and lower limit. So this is z square, so this is going to be 1 minus x square minus y square. Since the lower limit is 0, so we are ignoring this. Okay, now we will write this, that is dy dx. Okay, now here we can take common, that is 1 upon 2. 1 upon 2, we can take this outside of this integration because this is constant. Yes, 0 to 1 minus x square. Now we can open this bracket, that is xy into 1, that is xy minus, this will be x cube upon into y minus x into y cube dy dx. Now we are going to integrate this function with respect to y. whose limit goes from 0 to root over of 1 minus x square. So we will solve this part now. So here we have half 0 to 1. We are integrating this function with respect to y. So we'll keep x constant. So this is going to be x into y square upon 2 minus x cube y square upon 2 minus x y to power 4 upon 4. Limit goes from 0 to root over of 1 minus x square. Now we have to write dx here. Now putting the limits, integration 0 to 1 in place of y, because we have integrated this function with respect to y. So in place of y, we will put upper limit and lower limit. So this is x upon 2. Here we have y square. So this is going to be 1 minus x square. Lower limit is 0, so ignoring that part. Minus x cube upon 2. In place of y square, we will put this, that is 1 minus x square. Minus x to the power x upon 4. Here we have y to the power 4. Okay. So this is going to be 1 minus x square whole square. Okay. Since the lower limit is 0, so we are ignoring lower limit part. So here we have dx. Now in the next step, we will open this bracket as a formula, that is a minus b whole square. So this is going to be half integration 0 to 1. This is x upon 2 minus x square minus x cube upon 2, 1 minus x square. This is going to be x upon 4, 1 minus 2x square plus x to the power 4. Now closing this bracket and writing dx. Now in the next case, we will open the bracket of all the three terms. This term, this term and this term. So let us see. Integration 0 to 1. Here we have x upon 2 minus x cube upon 2, x cube upon 2 minus plus, this will become x to the power 5 upon 2 minus x upon 4 into 1, that is x upon 4 minus plus 2 4, that is half x into x square, that is x cube. Okay. Now minus plus minus x to the power 5 upon 4. Here in the second term, we had minus that is positive, x into x square, that is x square, x cube, 2 upon 4, that is 1 upon 2. Okay, I hope this step is clear. Now closing this bracket, and here we have dx. Now you can see x cube upon 2, x cube upon 2, negative, positive. These two terms will get cancelled. What is left? Okay, so here we can say integration 0 to 1. Here we have x upon 2, here we have minus x upon 4. So if we take common, that is x upon 2, here we have 1 and here we have minus half. In the same way, here we have x cube upon 2 with negative sign. Okay, minus x cube upon 2. Now coming to the part that is x to the power 5. Here we have x to the power 5 upon 2. Here we have minus x to the power 5 upon 4. So we can take common, that is plus x to the power 5 upon 2. So what is left, that is 1, and what is left, that is minus half. Now closing the bracket, that is dx. So in the next step, what we can say, this is half integration 0 to 1. Here 1 minus half, that is half. So half into x upon 2, that is x upon 4. This is as it is, that is x cube upon 2. Here 1 minus half, that is half. Half into this will become plus x to the power 5 upon 4. Now we will integrate this with respect to x. So this is going to be half. This will become x square upon half 2 into 4, that is 8. Minus this will become x to the power 4 upon 4 into 2, that is 8. Plus x to the power 6 upon 6 into 4, that is 24. Okay, limit goes from 0 to 1. Now on putting the limit, that is half, lower limit is 0, so we are ignoring that, that is we have to put only upper limit. So this is going to be 1 upon 8 minus 1 upon 8 plus 1 upon 24. So 1 upon 8, 1 upon 8 will get cancelled. What is left, that is 1 upon 24. So 1 upon 24 into half will become 1 upon 48, and this is my final answer. Okay. I hope that you have learned a lot from this video. If that is the case, then thank you so much. Thank you.